Welcome to the study on course of integral equation and integral transforms. Integral equation and integral transforms is a very important topic in applied mathematics. Before going into the course detail, which we must know about the motivation of the study. Actually, many initial and boundary value problems, they can be reduced to an integral equation. So, once the solution of integral equation is known, then we can know about the solution of the boundary value problem involving partial differential equation or ordinary differential equation. The history of integral equation dates back to 1826, when N.H. Abel, while solving the problem of finding the path of descent of a particle along a smooth curve in the vertical plane in a given time interval, reduced it to solution of integral equation. Later, in 1896, Volterra, he gave a theory on linear integral equations, where one of the limits of the integral is variable, and that theory after him is known as theory of Volterra integral equation. In 1900, Fredholm, he also studied integral equation and gave a theory of integral equations in which the limits of the integrals are constant. Now, next is, why do we study integral transform? Actually, many initial or boundary value problems consisting of differential equation, may be ordinary or partial, with appropriate boundary or initial condition, can be solved very easily by using integral transform. If we consider a boundary value problem or initial value problem with ordinary differential equation and proper boundary or initial condition, then proper choice of integral transform makes it possible to reduce the ordinary differential equation into an algebraic equation. It may so happen that it may be difficult to solve the differential equation, but with use of integral transform, we have reduced it to algebraic equation, which is perhaps easy to solve. So, this is the utility of the integral transforms. There are many types of integral transforms, but in this course we shall learn about 5 transforms. They are Fourier transform, Laplace transform, Mellin transform, Hankel transform and Z transform. The whole course structure is divided into 10 chapters, out of which from chapters 1 to 5 we will study about integral equation, while from chapters 6 to 10 we will study about the integral transforms. In chapter 1 we will know what is an integral equation along with their classification, and also how the integral equations occur. In chapter 2 we will study the theory of integral equation, namely the Fredholm theory, when the integral equation has degenerate kernel. In chapter 3 we will extend Fredholm theory to the integral equation with continuous kernel, that is more general form of kernel. And in chapter 4 we will study about integral equation with symmetric kernel. Finally, in chapter 5 we will study the solution method of solving Abel integral equations. So, this is all about integral equations. Next, from chapter 6 to chapter 10, we will study about the integral transforms. Chapter 6 deals with the study of Fourier transform, how Fourier transform comes from Fourier series, its properties and its use in solving partial differential equation and ordinary differential equations. Next, chapter 7 deals with Laplace transform, its properties and its application. In chapter 8, we have studied Mellin transform. Chapter 9 deals with Hankel transform, and chapter 10 finally we will study Z transform. So, this is all about integral transform, and I hope you will enjoy the course. Thank you.